Tic-Tac-Toe looks too easy for an interview until you try to design it cleanly. Then you need players, turns, a board grid, move validation, win detection, draw detection, and extensibility. In this video, we will solve tic-tac-toe like a real LLD interview. Clear diagrams, simple Java code, and one important pattern. Strategy pattern for winning rules. In an LLD interview, the order matters. Do not start with code. First clarify scope, then requirements, then the grid model. After that, draw classes, explain the move flow, introduce strategy pattern, and only then write code. This makes your answer sound like design thinking, not memorized code. Let us define scope clearly. We have two players, X and O. The default board is 3x3, but we will keep the board size configurable. Players take turns. The system rejects invalid moves. After each valid move, it checks win or draw. We are not designing online multiplayer, ranking, matchmaking, or a graphical UI. The goal is clean game logic that you can explain in an interview. Functional requirements are what the game does. Start a game, accept moves, validate cells, switch turns, and detect win or draw. Non-functional requirements are the design quality. The code should be simple to explain, easy to test, and not tied to console input or UI. The interesting requirement is extensibility. If tomorrow the interviewer says make it 4x4, the design should not collapse. Tic-tac-toe is naturally a grid problem. A move is not just a number. It is a row, a column, and a mark. The board owns the grid and validates whether a move is inside the board and whether the target cell is empty. This keeps validation close to the data it protects. Here is a design choice interviewers like. Should we store a list of moves or a two-dimensional grid? A list of moves is simple for history, but it makes cell lookup and win checking noisy. A grid is the natural model. You can directly access row and column, check whether a cell is empty, and scan rows, columns, and diagonals. For this problem, choose the grid. If you need move history, keep it separately. The class diagram is small, and that is good. Game coordinates turns and status. Board owns the grid. Cell stores one mark. Player has a name and mark. Position is row and column. Winning strategy is the important extension point. Game does not hardcode how a winner is detected. It asks the strategy. The move flow should be easy to say out loud. UI sends a row and column to game. Game asks board to place the current mark. Board validates the move and saves it. Then game asks the winning strategy whether this move won. If not, game checks draw. If the game is still in progress, it switches the current player. Notice that UI never manipulates cells directly. Strategy pattern means you encapsulate an algorithm behind an interface. The context here, game, holds a reference to that interface. For normal tic-tac-toe, the strategy checks rows, columns, and diagonals. For another variant, you can swap in a different strategy without rewriting game. That is the main design signal. Rules can change without breaking the game engine. Without strategy pattern, game becomes responsible for every rule. Normal win, larger board win, connect 4-styled win, bot mode, maybe even reverse tic-tac-toe. The if-else chain grows inside the main game class. With strategy pattern, game only knows that a winning rule exists. The rule itself lives in a separate class, so the design stays clean. We do not need state pattern here, but we still need game states. The game starts in progress. After each valid move, either someone wins, the board is full and it becomes draw, or the game remains in progress. Once status is won or draw, no more moves should be accepted. This is a common edge case interviewers check. Start with the smallest models. Mark can be X, O, or MTD. Game status tells us whether the game is still running, won, or draw. Position is a row and column. Player has a name and a mark. In an interview, these simple types make the rest of the code easier to explain. Board owns the grid and protects it. The placeMark method validates the position, checks whether the cell is empty, and then writes the mark. This is important. Game should not directly modify the array. Board is the boundary that prevents invalid moves from corrupting the game. This is the strategy pattern. Winning strategy defines the algorithm contract. Row column diagonal strategy implements the normal tic-tac-toe rule. It checks the row of the last move, the column of the last move, and both diagonals. For a 3x3 board, this is more than fast enough, and for interview clarity, it is excellent. The helper methods are intentionally simple. To check a row, scan every column in that row. To check a column, scan every row in that column. Because we only need to inspect the row and column touched by the last move, This is efficient and easy to explain. If the interviewer pushes for optimization, you can discuss counters, but do not start there. There is a useful trade-off here. You can scan the grid after each move, or you can maintain row and column counters. Counters make win check constant time, but they add bookkeeping and are easier to get wrong. For normal tic-tac-toe, scanning is clean and interview friendly. Mention counters as an optimization if the board becomes very large. Game is the coordinator. It checks whether the game is still active, gets the current player, asks board to place the mark, increments moves, checks winner, checks draw, and switches turn. Notice the dependency direction. Game depends on winning strategy interface, not a hard-coded implementation. That is exactly where strategy pattern helps. This is how you show usage in an interview. Create the board, create players, inject the winning strategy, and call play move. This also proves your code is testable. A unit test can create a game with a fake or real strategy and assert the status after each move. These are the edge cases to call out yourself. A move outside the board. A move on an occupied cell. Same player moving twice. A move after the game is already over. Both players accidentally using the same mark. Draw on the last cell. And board size changing from 3 to n. If you group these clearly, the interviewer sees that you're thinking about correctness, not just happy path code. Here is the interview formula. Clarify scope, model the board as a grid, create small classes, game, board, player, position, and winning strategy. Use strategy pattern for win detection so rules can change. Write simple Java code, then call out edge cases and trade-offs. That is a complete tic-tac-toe LLD answer.